GCP Platform and Cloud Engineering Part 26. This episode has 21 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Scenario: customer-facing latency increases after a release. How would you lead the response? Here's a strong way to approach it. Confirm impact. Compare before or after metrics. Check traces, logs, dependencies, database queries, cache behavior, and resource usage. If slow impact is severe, roll back or shift traffic. Communicate status, preserve evidence, and create follow-up actions such as performance tests, canary gates, or better dashboards. Nice. Let's continue. Question 2. How do error budgets influence release decisions? Here's a strong way to approach it. Error budgets quantify how much unreliability is acceptable within a slow window. If the budget is healthy, teams can ship faster. If it is burning too quickly, teams should slow risky releases and prioritize reliability work. This creates a shared language between product speed and service stability. Great. Moving on. Question 3. Scenario: error budget is almost exhausted but a business feature must ship. What do you recommend? Here's a strong way to approach it. Assess feature urgency, risk, rollback options, blast radius, and current service health. Consider canary release, feature flags, off-peak deployment, additional monitoring, or delaying non-critical parts. Make the decision transparent with business and engineering stakeholders. Alright, next question. Question 4. How do you improve developer productivity through platform engineering? Here's a strong way to approach it. Provide golden paths, reusable CI or CD templates, Terraform modules, self-service environments, standard observability, secure defaults, documentation, and support channels. Measure developer experience using lead time, onboarding time, failed deployments, support tickets, and satisfaction feedback. Let's keep going. Question 5. Scenario: developers bypass the platform because it is too slow. What would you do? Here's a strong way to approach it. Interview users, map pain points, reduce approval friction, improve templates, automate common requests, publish clear docs, and define support SLAs. Keep necessary controls but make the secure path easier than the workaround. Platform adoption depends on trust and usefulness. On to the next one. Question 6. How would you create and maintain engineering standards? Here's a strong way to approach it. Define standards collaboratively, keep them practical, version them, provide examples, and enforce critical ones with automation. Standards should cover branching, CI or CD, IAC, naming, tagging, security, logging, monitoring, runbooks, and production readiness. Review them periodically as tools and risks change. Good. Here's another one. Question 7. Scenario: different teams use different CI or CD tools. How would you standardize without causing disruption? Here's a strong way to approach it. Create a target reference architecture and migration roadmap. Start with common controls such as artifact storage, scanning, approvals, and observability even if tools differ. Provide templates for preferred tools. Support migration gradually, and measure improvement. Avoid a big bang migration unless required. Nice. Let's continue. Question 8. How do you handle change control in a high compliance environment? Here's a strong way to approach it. Keep traceability from requirement to code, tests, artifact, approval, deployment, and rollback. Automate evidence collection through CI or CD. Use approvals for production. Document risk and impact, and maintain audit logs. Good change control should reduce production risk while preserving delivery flow. Great. Moving on. Question 9. Scenario: an emergency production fix is needed outside normal change windows. What is your process? Here's a strong way to approach it. Use an emergency change process with incident context, risk assessment, minimal approved change, peer review where possible, clear rollback, and post-change documentation. After the incident, reconcile Git or Terraform state and complete retrospective actions. Emergency access should be controlled and auditable. Alright, next question. Question 10. How would you design release management for weekly production deployments? Here's a strong way to approach it. Use release calendars, automated testing, artifact promotion, environment parity, deployment checklists, approvals, feature flags, rollback plans, and post-release monitoring. Keep releases small and frequent. Track deployment frequency, change failure rate, and lead time. Let's keep going. Question 11. Scenario: A weekly release fails repeatedly in production. What systemic issues would you investigate? Here's a strong way to approach it. Investigate test coverage, environment drift, missing dependency tests, large batch size, manual steps, weak rollback, unclear ownership, poor observability, and release pressure. Fix the system rather than blaming individuals. Introduce smaller changes, better gates, and post-release verification. On to the next one. Question 12. How would you design architecture diagrams and deployment guides that engineers actually use? Here's a strong way to approach it. Keep them current, simple, and connected to real operations. Include service boundaries, dependencies, data flow, network path, IAM, deployment flow, failure modes, and ownership. Store diagrams and guides near code when possible and update them as part of change review. Good. Here's another one. Question 13. Scenario: A production incident happens and there is no runbook or architecture diagram. What do you do after recovery? Here's a strong way to approach it. Create the missing runbook and diagram as part of the post-incident action plan. Capture symptoms, root cause, detection gaps, remediation steps, owners, and prevention work. Assign due dates and track completion. Documentation should be treated as a reliability control. Nice. Let's continue. Question 14. How do you approach threat modeling for cloud workloads? Here's a strong way to approach it. Identify assets, users, trust boundaries, data flows, entry points, and likely threats. Review IAM, network exposure, secrets, data storage, logging, supply chain, and dependency risks. Convert findings into prioritized mitigations and CI or CD or policy controls where possible. Great. Moving on. Question 15. Scenario: A new cloud design includes public endpoints and sensitive customer data. What questions would you ask? Here's a strong way to approach it. Ask why public exposure is required, what data is processed, authentication and authorization model, encryption, logging, data retention, WAF or DDoS controls, private connectivity options, audit requirements, and regulatory constraints. Recommend private access or least exposure design where possible. Alright, next question. Question 16. How do you incorporate customer fairness and regulatory expectations into engineering decisions? Here's a strong way to approach it. Consider how outages, data issues, security weaknesses, or biased automation affect customers. Build controls for reliability, privacy, auditability, access, and transparency. In regulated environments, engineering decisions should protect customers, maintain integrity, and produce evidence for compliance. Let's keep going. Question 17. Scenario: A reliability improvement increases cost. How do you justify it? Here's a strong way to approach it. Compare cost with business impact, incident reduction, customer impact, regulatory risk, slow improvement, and operational toil reduction. Present options with trade-offs, such as autoscaling, right-sizing, multi-zone redundancy, or targeted HA only for critical paths. Good justification links engineering investment to risk and outcomes. On to the next one. Question 18. How do you balance cost efficiency with high availability? Here's a strong way to approach it. Classify services by criticality, define slows, use autoscaling, right-size resources, avoid over-provisioning, use committed discounts where suitable, and apply HA patterns only where justified. Cost optimization should not blindly reduce redundancy for critical customer journeys. Good. Here's another one. Question 19. Scenario. Cloud costs rise after adopting Kubernetes. What would you investigate? Here's a strong way to approach it. Check node utilization, requests and limits, idle node pools, over-provisioned workloads, autoscaler settings, logging volume, load balancers, persistent disks, image storage, data egress, and non-production clusters, add labels, dashboards, budgets, and ownership-based reporting. Nice. Let's continue. Question 20. How would you demonstrate senior-level ownership in this cloud engineering role? Here's a strong way to approach it. Show examples where you identified systemic problems, aligned stakeholders, designed a practical solution, implemented automation, measured outcomes, documented standards, mentored others, and improved reliability or delivery. Senior ownership means driving outcomes, not only completing tickets. Great. Moving on. Question 21. Scenario. You are joining this team in the first 90 days. What would your plan be? Here's a strong way to approach it. First 30 days. Understand services, incidents, architecture, CI or CD, Terraform, cloud accounts, observability, and stakeholders. Next 30 days. Identify top reliability, security, and delivery bottlenecks. Then deliver quick wins such as alert tuning or pipeline fixes. Final 30 days. Propose a roadmap for slows, IAC standardization, DevSecOps gates, runbooks, DORA metrics, and platform improvements with measurable outcomes. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.